Hello dear friends, welcome to a lecture on numerical methods. In this lecture we shall study system of linear equations or solutions of system of linear equations. In this there are main methods which are Gauss Elimination Method, Gauss Jordan Method, then factorization method and iterative method. In this lecture we shall study Gauss Elimination Method and also Gauss Jordan Method. I have written here system of linear equations in three unknowns. Consider the system is written in this form: a11 x1 plus a12 x2 plus a13 x3 is equal to b1. So these are three equations in three unknowns. The unknowns are x1, x2, x3. Their coefficients we have written in this notation: a11, 11 stands for first equation, first coefficient, 1 2 stands for first equation, second coefficient, and so on. b1, b2, b3 are the constants on the right side. And for this system, we know earlier we can write the system in matrix form, and that generally written as A into X is equal to B, where A is the coefficient matrix, X is the column matrix of unknowns, that is x1, x2, x3, and B is the matrix of constants on right side. So there, that means this system 1 is written in the form Ax is equal to B, and further we perform row transformations on matrix here A and the matrix B. So thus this matrix X remains unchanged if you use the row transformations to obtain the solution. And therefore this matrix X, without writing matrix X, we write the matrices A and B together, and that is known as augmented matrix, or this matrix will be matrix AB, and that matrix we have written here, which is known as augmented matrix of the system. And that the A matrix, A part is this one, where this is the coefficient matrix or matrix of coefficients of x1, x2, x3, and that are written as a11, a12, a13, etc. And these are the coefficients from second equation, and these are the coefficients from the third equation, and these are the constants on the right side: b1, b2, b3. So here we have not written x1, x2, x3 as the matrix of unknowns, and thus this is the augmented matrix. And the method of elimination is that we eliminate, first we eliminate x1 from second equation and third equation using the first equation, that is this a11 x1, and then we eliminate x2 from the third equation. So thus we convert this matrix into upper triangular matrix. Upper triangular matrix, that is the elements below the diagonal, we convert to 0, and that means these elements a21, a31 and a32 we shall convert to 0 using row transformations, or that means using here the first equation we will convert this a21 and a31 at the first stage to 0, and after that using the second row we will convert this element a32, second row or second equation we shall convert this element to 0, and thus after this augmented matrix is converted into upper triangular matrix, we write the system again in this form and solve the system by using back substitution. So this is the method which is known as Gauss Elimination Method. That means we are eliminating the unknowns from this second and third equation. That is, first we eliminate x1, that means we convert these two elements to 0, and next we eliminate x2 from third equation, and that means we convert this element to 0. Now how to convert these elements to 0 using the row transformations? And see, for this we make use of the first at the first stage. There are mainly two stages in this method. First, to convert these two elements to 0, we multiply. We have to make the coefficients equal and then subtract, or we make the coefficient negative of the coefficient of this second equation and subtract. So here it is a11 and here it is a21. So we first multiply the first equation by minus a21 divided by a11. So multiply Here now the pivot element is A11 at first stage. First stage, the pivot is A11. That means we divide by A11 here, these two elements, and then we multiply by this element by A21 here, or we multiply first equation by negative A21 divided by A11. See, if you multiply the first equation by minus A21 upon A11, then the coefficient will become negative A21, and then add it to the second equation, so that this term will be eliminated, and add it to second equation. Similarly, we multiply the first equation by minus A31 divided by A11. Also, multiply equation 1, first equation, by minus A31 divided by A11, and add it to the third equation. So this is the first stage, and after performing this, these elements will be converted to 0, because we are multiplying the first row, and this operation is to be effected on this augmented matrix, and in the matrix form the operation will be, see, R2, this is the second row, R2 minus, that is we use the transformation R2 minus the first equation is multiplied by A21 upon A11, and that means first row is to be multiplied by this, and then it is added to the second equation, means second row, that is the first transformation, or this the transformation is this one, R2 minus A21 divided by A11 R1. And what about the second in the second transformation we want is multiply the first equation by minus A31 upon A11, and then add it to third equation. So therefore the third equation is to be added, means we have to write the third row first, R3. In R3 we have to add this multiple of first equation, that is minus A31 upon A11 times R1. So perform these operations, or the transformations are these, and then the augmented matrix becomes, then 2 becomes. See, there will not be any change in first row. We are making use of first row because the pivot is the element A11. We are actually making use of this to convert these two elements to 0, and there is no change in the first row. The first row will be as it is, A11, etc. And this element will be converted to 0. This element will change, and the changed elements we shall denote by another notation, prime notation, or A22 dash, A23 dash, and B2 dash. And this element is converted to 0, and this this will be changed, and we can write this with another notation as the prime notation for this. So this is the matrix now. Further, only one element is to be required to convert to 0 to get the upper triangular matrix. These are the diagonal elements. Row number, column numbers are equal, and below that these three are the element to be converted to 0. Now to make this or convert this element to 0, now the pivot is this element. So therefore we have to multiply the second row. Now we perform the operation, or do the transformation. As now, see, the second row is to be multiplied by A23 dash negative, and that then divided by A22, and then it is to be added in the third row, and that means the third row is to be added with negative A32 A22 dash divided by A22 dash times R2. So if you do this transformation, then this element will be converted to 0, and there is no change in first row and second row, only the third row will change, and the corresponding matrix will be, I shall write here, the matrix will be converted to this one. No change in again the first row, and this is B1. Second row also there is no change. And third row, the element will be converted, there will be change in third row because we are changing the third row. In third row, this times of R2 second row is added, and this element will be 0, and that element will be changed to new element, and new element we will denote by other notation. Dash or double dash denotes the changed element, and this B3 will also change, and that will be this one. So thus we have converted the augmented matrix into upper triangular matrix. Now the system can be written in this form, earlier equivalent form to this form, and then the equations can be solved by back substitution. Means last equation gives the value of z or x3, and then using that value we get x2, and using that x2 and x3 we get the value of x1. So this method is known as Gauss Elimination Method. Now there is another method which is Gauss Jordan Method, and that method in this stage not only the element x2 is eliminated from third equation, but x2 is also eliminated from the first equation. Then that means we can convert this element also to 0. So for this purpose, what we have to perform the transformation is also perform the transformation or do the transformation. Transformation for this will be at the same time, that is R1 minus multiply the first row by this element A22 dash, and then divide by multiply this element. So the element will be R1 minus A, the element is A12. A12 is to be made equal to A22 dash, and then this will be converted to 0. So this will be multiplied by A22 and dash and divided by A12. So times R2. So I have written opposite. So this element first we have to divide by A22 dash and then multiplied by A12. So here you see this is to be divided by A22, and so it becomes 1, and then it is to be multiplied by A12, and then it becomes negative of this times R2. Perform this. So the matrix now becomes like this. Then the augmented matrix will be, so this element will be changed, and we denote that element now by another notation A11 dash, and this is converted to 0. This will be changed A13 dash B1 dash, and no change in the second row, and this will remain as it is, and also there is no change in the third row. And see what is the change in this modification. Instead of making only these three elements to 0, converting these two elements to 0, we have converted this element also to 0. That means we have eliminated x2 from the first equation, and from also the third equation. So this is modification in this Gauss elimination method, and that method is known as Gauss Jordan method. So this is Gauss Jordan method. That means x2 is eliminated from first equation and third equation. So thus we have seen the Gauss Elimination Method or Gaussian Elimination Method and Gauss Jordan Method. Now we shall solve this problem so that this will be more clear to you. So solve this following system by first Gauss Elimination Method and second Gauss Jordan Method. So this is the problem. Now we shall solve the problem. So first we shall write the augmented matrix. So solution for this is the augmented matrix. Now it is easy to write. It is matrix of coefficients together with matrix of constants on right side, that is column. So it is 2, 2, 1, 1 and then 10. This from second row, second equation 3, 2, 3, 18 and 1, 4, 9, 16. So this is augmented matrix. Now we want to convert. First we shall use Gauss Elimination Method. First we will use Gauss Elimination Method. And we convert this matrix to upper triangular matrix, means these three elements are to be converted to 0 and the pivot is this element 2. So what we shall have to do is divide the first row by 3 and then multiply, or we have to divide the first element by 2 and multiply by -3 and then add it in the second row. Similarly for this one, so we have to divide the first row element by 2 and multiply by -1. So that the transformation should be written as perform. See, we perform this transformation R2 minus. So this is to be multiplied by -3 and divided by 2. So this element is to be considered first, -3 divided by 2 and times R1 and similarly R3 for this. So we have to multiply by 1 and divide by 2 and with negative sign, -1 by 2 times R1. So this is the transformations to be performed on this augmented matrix. There is no change in the first row. So I shall write the system here, or matrix here I shall write. See, there is no change in the first row and the row will be 2, 1, 1, 10. And now see, the second row changes because it is 3 minus 3 by 2 into 2, or you can write the elements like this. This is the second row, that is 3 minus 3 by 2 into R1. What is the element in R1? That is 2. And therefore this is 3 minus 3, which is 0. Similarly here it is 2 element R2 minus 3 by 2 times element of R1, that is 1. So 2 minus 3 by 2 and that is 1 by 2. And next we are only performing first this, and that is 3 minus, this element is 3 minus 3 by 2 into 1 and that is 3 minus 3 by 2. So which is 3 by 2 again. 3 minus 3 by 2 is 3 by 2. And further 18 minus 3 by 2 times 10. This is 18, this element is 18 minus 3 by 2 times the element in R1 is 10. So 18 minus, it is 15, that is 3. You should check the calculations. So thus this is a second row transformation we have done, and that means we have eliminated x1 from the second equation. Now the third row transformations is R3 minus half times R1. So this is 1 minus half into 2. So it is 0. So that we have decided the transformation to make these two 0. So it is see, divide by the element here, whatever the element present here we have to divide, and whatever the element is here we have to multiply and take the opposite sign. If it is positive, then we have to write the negative sign. So this is 1 minus 1 is 0, and then 4 minus half. So it will be 4 minus 1 by 2 into 1, and that is 7 by 2, this element. And next is 9 minus half, so it is 18 minus 1, that is 17 by 2. And next will be 16 minus half times 10, or 16 minus 5, that is 11. So these are the elements we get at the first stage. So we have done the first stage in Gauss elimination method. Now what remains is to convert this element to 0, and for that we make use of the second row, and this is now the pivot element. So we have to actually divide by half and multiply by 7 by 2. So but you see, these are to be made numerically equal and with opposite sign, and then we have to subtract. So if you multiply this by 7, the element becomes equal, means 7 times R2, and then subtract from R3. So the transformation is performed 7 times, let's see, R2 minus 7 times R3 minus 7 times R2. Third row will change, so R3 minus 7 times R2. This is the transformation to be performed, and we get the augmented matrix becomes, only the third row will change, and first row, second row will remain as it is. So this is 2, 1, 1 and 10, 0, half, 3 by 2, 3. And now the third row is 0, because this element is 0, this will not be affected. And now this is 7 by 2 minus 7 into half, that is 7 by 2. So that is now 0 as required. So according to that only we have decided this transformation. So this is R3 minus 7 times R2, and it becomes, the element is 0 now. And now the next element is 17 by 2. 17 by 2 minus 7 times 3 by 2. See, it is a 17 minus 21 by 2. 17 minus 21 is 4, and which is negative, minus 4 by 2 is minus 2. And next is 11. 11 minus 7 times 10. You see, this element is not 10 but 3. R2 we have to take, and this is 11 minus 21. So 11 minus 21 is minus 10. This is the augmented matrix we have obtained, and thus we have converted the augmented matrix into upper triangular matrix, and we now rewrite the system in usual form. So this is equivalent to, and the system is now 2x, this is coefficient of x, y, z, and this is constant on right side. 2x plus y plus z is equal to 10, and second equation is this is 0x and need not to be written, half y plus 3 by 2 times z and is equal to 3. And third equation, these two are 0, this is minus 2z, minus 2z is equal to minus 10. So thus we obtain this system, and now you see from this system we can solve the equations easily by back substitution. Back substitution means last equation is to be solved, we get the value of z, and this value can be used in the second equation, and then we get the value of y, and then both y and z can be used in first equation to get the value of x. So thus by back substitution the equations will be, so these give, or by back substitution we get from the last 2 minus 2z is equal to 10, minus 2z is equal to minus 10, this implies z is equal to 5, and from the therefore second equation, half y plus 3 by 2 z, what is z? Z is 5 is equal to 3, and this implies what is the value of y? You see half y or y by 2 is equal to 3 minus 15 by 2, or which is equal to say 9 minus 9 by 2, and thus this gives y is equal to minus 9. And from the first equation we write these values: 2x plus y is minus 9 and plus z is 5 is equal to 10, or this gives 2x is, or this implies 2x is equal to 17. This is minus 4, and if you transfer on that, that is 14. 2x is 14 and x is equal to 7. So thus we have obtained the value of x as 7, y is minus 9 and z is 5. So this is the Gauss elimination method. Now what about the second, Gauss Jordan method? That is a modification of Gauss elimination method, modification in the second stage only. The first stage is the same. Now for B part, so we have obtained the solution here. Now we shall use the second method to solve this, B, that is Gauss Jordan method. For Gauss Jordan method, we make use of this augmented matrix. Say suppose this as 1. From augmented matrix 1, on augmented matrix 1, we perform row transformation so as to eliminate x2 from first and third equation. First, that means we convert this element to 0 and this element also to 0. And already we have done this step here in Gauss elimination method. That means this element is converted to 0. Only this remains. And to convert this to 0, make use of R2. See here it is 1 and here it is half. So we want 1 here. So multiply this by 2 and then subtract from subtract that element from first equation. So that means perform this operation, that is R1 minus 2 times R2, and this is the same, R3 minus 7 times R2. So we get, now there is only a slight modification. Instead of making this only element to 0, we have to make or convert this element also to 0. And see R1 minus 2 times R2. So refer this. R1, that is 2, and because this is 0, this is unchanged, that 2. It is 1 minus 2 times half, that is 1 minus 1, which is 0. And this is 1 minus 2 times 3 by 2. You see 1 minus 3, that is minus 2. And this is 10 minus 2 times 3. So 10 minus 6, that is 4. And no change in the remaining elements, that will be like this: 0, 0, half, 3 by 2, 3. And this transformation, if you perform, we have done it already, and third row will be obtained as like this: 0, 0, minus 2 and minus 10. And now the system corresponding to this matrix will be, so we this is equivalent to, write the system in this form. So what is the, I shall write on here itself. It is 2x. Now y is absent. So 0y. And what is z? Z is minus 2. Minus 2 times z. 2x minus 2z is equal to 4. See, second system remains the same, and third is also the same. So only this is the change. That means the element here we have converted to 0. Actually we have eliminated x2 from the first equation also. Solving these, see, this is the system obtained. So we should write after this the system, this is equivalent to this one, and now solve. And this can be solved as earlier. From this we can get z is equal to, we get as earlier z is 5, and when z is 5, what we have obtained, y is equal to -9, and if put the value of z here in this first equation, we shall get 2x minus 2 into 5, and that is equal to 4, or therefore 2x is equal to 14, and therefore x is equal to 7 as earlier. So this is the slight change in Gauss elimination method, which is known as Gauss Jordan method. So in this way we can use Gauss elimination method and Gauss Jordan method, which are numerical methods to solve a system of linear equations. So thank you for watching the lecture.